is algebra? Well, algebra gives us the building blocks to create mathematical statements and models to represent real-world phenomena. We establish a relationship between quantities that change or vary. All right. So one of the main fundamental ways that we use algebra is we take a bunch of very complex real-world ideas and we try to think about like how can we um, quantify this? How can we come up with a formula that sort of explains this behavior that we see? So what's common in the real world is we have these variables. Variables are different things that change with in relation to generally, let's say, something that's changing with time. So a variable could be speed. A variable time is also a very common variable. If you're taking economics or a business course, then variable can be like changes in profit. Your variable can be changes in price, changes in demand. So we have all these different things that change and we want to express them in a formulaic way. So that's where algebra comes in. And we usually use lowercase letters to represent these quantities. Commonly throughout this course, you'll see X used to represent variables. Y is also common, Z. But again, any letter can be used. So if you're taking a physics course, you'll see T is commonly used to represent time. If you're taking an econ course, P is often used to represent price. The other type of quantities that we deal with are quantities that stay fixed in value or amount, or size, depending on what you're working with. So these are always referred to as constants. Now, something you'll see later is even constants can be expressed using letters. So you may see constants being expressed as A or B. So it is important as we go along to recognize when is a letter representing a variable and when is a letter representing constant. Generally, if you see a letter in an equation, it is representing a variable. Any time you see constants represented as a letter, those will occur in formulas. And in formulas, and usually it would be specified that it's a constant. Okay. But at the moment, all we are going to be the examples we're looking at, we're considering all the letters to be variables. Okay. Now, in algebraic expressions, the simplest piece of the algebraic expression is the term. Okay. So let me just check something really quick. Yeah. Okay, so it's a term. Now, the term has a few components. Every term will have a base variable, which includes an exponent. So as you can see here, our base variable is x, and its exponent is 3. Now, let's say you saw an algebraic expression as such. Let's say we had 5x only. You still have an exponent in this situation. The exponent is 1. But generally, we do not write the exponent of 1. So there's always an exponent. If you do not see an exponent, that exponent is 1. So typically, again, we don't write it. In every other case, the exponent will be given, whether it's a fractional exponent, whether it's negative, you'll always see it. The only time you don't see it is if it's 1. The other part of a term is every term will have a number in front of the variable. This number is called the coefficient. Now, similar to the exponent, if you're given something like, let's say, y cubed, you still have a coefficient here, even though there's no number here. So it's also 1. Okay. So if you don't see an exponent or if you don't see a coefficient, that means it's 1. Any term that has no variable attached to it, as we see here, is just a constant number. So we see this 6, so we have 5x cubed minus 6. This is a constant. Now, in actuality, you can write a constant number with a variable. And the way that would look is, in the case of the 6, it would be 6x to the power of 0. This is equal to 6 times 1, which equals 6. So it is a way to express a constant in the general term form, where you have the coefficient and a variable and exponent. And that's because any variable to the power of 0 is equal to 1. Hence, you just end up with the coefficient, which just becomes your constant. Okay. Now here's a few more examples of terms and constants. So here we have 5x to the power of 4. This is the 5 is the coefficient, x is the variable, and then the exponent of x would be 4. Next, we have negative 2a. Well, in this case, the variable is a. And notice there's no exponent here, hence its exponent is 1. And the coefficient is the negative 2. Finally, we have 1/3 p to the negative 1. So p is our variable, with negative 1 is the exponent, and 1/3 is our coefficient. When you're adding or subtracting a string of terms, that's when you end up with an algebraic expression. So these are all the examples of algebraic expressions. So this is a term on its own. 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 So these are a string of terms. So we can have a bunch of different terms. So on. So each one that we're adding or subtracting is, say this minus, is a term. And this whole thing all together is the expression.